Okay, so today's talk is called The Defender's New Clothes, and we're going to look at some cybersecurity solutions and maybe explore how we do think about them, or maybe how we should be thinking about them. A little bit about me. Originally from Norway, I've spent the last 20 years in Australia. I started my career as a developer, moved into system administration, did about a decade of dedicated pen testing, and then moved into security research, and now it's a bit of a mix at the moment. I started working internally for an Australian company called Seek, and we do job placements. So process a lot of PII, and yeah, I'm on the internal security team there. Right, the setting for this talk is a story that you may well know, of an emperor who's a bit vain and gets approached by some swindlers who convince him that they can make him fabulous clothing with magical properties, which can only be seen by intelligent people. And instead of actually providing him with clothes, they just pretend. They pretend to weave the clothes, they pretend to dress him up. There's a parade, and nobody at any point says anything because they're afraid to be laughed at for not being able to see the clothes. And during the parade, the little boy points out that the emperor is in fact not wearing any clothes. And as soon as somebody voices the concern out loud, the illusion fades and everyone can see that the emperor is naked. So I've got a bit of a street art here where he's carrying a suitcase full of cash, which I think is appropriate because the defense industry is a very money-oriented industry, I suppose you could say. We spend a lot of money budgeting for things like firewalls, antiviruses, web application firewalls, and we may not be getting the return on investment. So the analogy here is that the defense solutions are the clothes, and they may in fact not be there. And the defender, I suppose, in our case, is anyone who identifies as a defender, someone whose responsibility or desire it is to keep networks, systems, data secure. And some of the things they might use to do this is web application firewalls, antivirus, hardening, incident response, etc. So we're going to look at the different solutions and sort of determine whether or not they are in fact a piece of clothing or merely something we pretend is a piece of clothing. And we often look at security software as a solution to a problem, as opposed to, and when you're trying to solve a problem by adding complexity to the problem, you may in fact make it worse. Particularly the bit about supply chain nightmares in the last 2 years or so, we've seen a lot more of this, where security software is being targeted. There was a sonic wall, remote code execution, zero-day active exploited this week. And so perhaps we do need to reconsider what security software is and how we use it. All right, so what's the solution on your network? We know the boundaries. You might have a Nessus box where every VLAN is truncated at the Nessus box because they need to be able to scan everything on your network. Obviously, if your Nessus box gets compromised, you have a flat network for the attacker. How effective is your WAF? I've never met anyone who had a good way to measure a WAF. And of course, as we see, if we accept the fact that security software has vulnerabilities in it, how do we secure the security software? Right. And I will be picking on some vendors. That doesn't mean that other vendors aren't equally bad. So, for example, do not overestimate your network security. The amount of times as a pen tester I've come into a network, plugged in, found the management interface with default credentials on the network side, as opposed to its own dedicated network, is quite high. And obviously at that point, all the money that you poured into these security controls are non-existent, because I log in with default credentials, not just turn off or add myself as an exception, whatever the situation may be. So I'm going to talk about a story. The story is basically a pretty standard one that you see in bug bounty today, or modern web applications. There's an attacker, there's a website with some juicy data in the database, and in between there's a web application firewall. We can't bypass the web application firewall by connecting directly to the IP of the web server, so we have to go through the firewall. And so we'll start off with just some examples of what are the things, one particular attack that I like to call the APT capability attack. If you know how to do this, according to some defenders, though, no, you are a nation state capability, because most attackers wouldn't think to do something like this. So this is an example of how, as things are coming in through, the load balancer or the cloud before they hit the back end, as we saw in this case, we had a WAF in front, but you might also see an AWS load balancer. In this case, someone's trying to prevent access to the API docs, which is documentation for an API that exists on the back end, and they're using a path pattern in the load balancer to do that. So if you try to access, example, the API docs, it gives you a 401 per the path pattern. But because it's string matching, if you make it the same but a little different, by introducing multiple slashes, you'll get a 200 OK, because it no longer matches the pattern. Now I call this the power of slash. And you might see throughout this presentation that the power of slash is very powerful. And the power of slash is very effective. And the power of slash shouldn't work, in my opinion, but it does. So, in our case, we didn't have a load balancer denying us access. It's a WAF. So we're looking for ways to bypass a WAF. Base64 is a way to bypass pretty much all the WAFs. It's pretty much a feature rather than a bug. And I guess the reason why WAFs generally don't inspect base64 is because it's costly, and the data might be encrypted, and so you're throwing CPU cycles at nothing. That of course means that one of the bugs in OWASP top 10, which is unsafe deserialization, typically isn't covered, because that data tends to be base64 encoded. And so now you have a bug class that will sail past most enterprise WAFs. Good. If you do run into one that maybe does base64 inspection, there is some base64 padding things you can do, or there are also, I've seen some cases where people string match base64 encoded content. So like cat etc password will have the same base64 string every time. By using padding, you can bypass string matching for those things as well. Cross-site scripting is another bug that you'd like your WAF to block. And for the ones where it's tag-based injection, you might have some success. If you're ever injecting inside a JavaScript context, you will not be able to block it, because JavaScript is Turing complete. So the one payload that I usually do is a basic fragmentation. So I assign a document to a variable, and then I use that variable. I split up the actual payload into multiple writes, so that I don't trigger, matching on keywords like alert, and then just write it out, and that works. Robin also recently posted a split XSS where you can use multiple injection points and multi-line comments to change the content, the context of what is HTML and what is script by terminating and starting multi-line comments. So that's also a bit of a niche thing, but it works. In terms of the split XSS, I don't think we can ever really block that, because it just, the individual context can be so staggered, although I suppose you could block multi-line characters. Here's another one, another reason why JavaScript-based context just doesn't work, because you can Unicode all sorts of things. So here's a cuneiform alphabet-based alert one, which is something you wouldn't typically string match for. This could be swapped with emojis or any number of other things, and it'll still work. And the base concept is, if you look up in the corner, it starts by defining an empty string, and then by referencing that empty strings with like pluses and minuses and as an array, etc. You can cause it to return things as strings rather than objects, or convert the object back into a string, and then that way extract the characters that you need for an alert one. Right. So back to the story. I'm looking at this website and I've found a traversal. And your WAF should block directory traversals. There are some type of traversals that generally don't block. The first one being a relative traversal, and the reason why that tend not to work is because you might have a relative redirect as part of your logout. In logout # redirect ... index.pp, that's a valid redirection in a lot of cases, and so you don't necessarily want to block that. And so we can look for things like robots.txt to determine whether or not we have a relative traversal from where we are. Non-traditional traversal, I was actually really surprised that worked, but it does. And then of course multi-part traversal, where different parts of the string gets put together into an actual string at the end. And just like with the multi-point injection for XSS, that's so context specific. I don't see WAFs effectively blocking these ever. And so just to show you that this works, Cloudflare, you go to // easy password. This is obviously not an actual underlying vulnerability here. The way WAFs work is when they find something, or they see something that matches an attack, they will block it. So by just putting a random parameter in the query string, you can trigger the WAF behavior, even though there is no underlying vulnerability to actually be exploited. And you can see Cloudflare blocks this because it says, well, this is a directory traversal attack. This is not allowed. And so again, using the power of /, we change the look and the feel of this traversal string to something else, and Cloudflare says, oh, well, that isn't a directory traversal then, and lets you in. And again, you can see like I'm not actually getting any data back because there isn't an underlying vulnerability here. This is just showing that the attack detection just isn't working. But on the real website that I was doing this against, that was successful. So I wrote this into a tool called Travesty that does a few different type of attacks or variations on directory traversal attacks to get around WAFs. And it's currently working. I don't know how much longer it will keep working. But if you're pen testing something at the moment, yeah, get in while it's still a valid technique. So we get directory traversal. We can leak relative files, leak source code, and identified a local file inclusion because it's a PHP app. But I don't have a local file to include, and I can't just submit a PHP string and that includes proc self environment, which technically I could with this power of /. but the PHP string still gets blocked. Luckily, looking around a bit more, I found a script that writes to log. It has file rotation, which is great. So if the WAF blocked something or it messes up through encoding, we can rotate out a clear version of the file. It's browser accessible, so I can access the file in the browser and verify that the injection was successful. And the WAF says, you're sending PHP code, you're trying to do exec, this is not allowed. So again, we need to bypass the web application firewall. And so we return to my old friend, fragmentation. And so I mentioned earlier that Robin had this for XSS, and we independently found it about the same time. He blogged first. But turns out actually quite a few people have discovered this technique independently in the past, so it's not unique, but that's what I came up with at the time, and it works. And so we can see here that we define first the start of a PHP, and then an eval, and then the bracket and the variable that we're evaluating comes later. And so because PHP ignores everything outside of PHP tags, the other stuff doesn't matter, and the stuff that's in between the PHP sections, by using multi-line, we get PHP to ignore that. So PHP basically just sees the eval statement. So now we have a way to corrupt or inject into the log file to get a shell. And again, I wrote a tool to do that. This is PHP Omelette, and it will take a string of PHP code and fragment it, as you can see below. So we use that, write a file to the log file, use a relative traversal to local file, include the log file, and execute PHP code. But unfortunately, we can't run commands because there is hardening in the way. And PHP hardening, if you Google it, you'll get a different list to what's shown here. This one is hyper-focused on commands to the point where they've blocked escape shell command and escape shell arg, which are actually safety functions for PHP. But it doesn't really matter if you block this specific set of functions or if you block the standard set of functions for PHP hardening. They're both ineffective. I imagine that this is what sysadmins imagine. They're like, yeah, we have a WAF, we have hardening, we have. They also had a local mod security on the box, and hackers will sort of give up. But we don't give up. We're going to hack the planet. For every step that I have overcome, from detecting a file include to getting a bypass, to getting code injection, to getting a local file include, like when I'm this close to executing commands, I'm not going to walk away. So since we can't execute commands through PHP, we need to look at some alternatives. And luckily, there's a lot of functions still available that are not blocked. For example, you can see that they actually blocked copy and rename. But since they don't block unlink and file open, I can do all those functions. I just have to do them through other steps. They also block chmod, but not umask. Right? These are all same but different. So the solution to this was to write a htaccess-based shell, which can run commands through server-side includes, which is a standard Apache module. We can't access the htaccess shell from the browser to execute the commands that way because the WAF blocks it. But luckily, we have curl exec in the PHP shell. So now we have a traversal to a local file include, to a curl exec, to a htaccess shell, which then runs commands all through base64 encoding to not trigger any of the WAFs or mod security. And yeah, now we can run commands, right? We're winning. But that's only the initial entry point. Right? We still want to be able to get root access. In this case, that was pretty simple. We show that there's a process called process email PHP that's running as root, and it was running on and off periodically. So we assume it's cron tab. There's a cron tab directory that contains a file with the same name. You know, all odds are on. So write some PHP code to dump its shadow and crack the passwords, and then go looking for who's responsible for the box, so that we can get this remediated. And that's the story. Yeah, you might question whether or not is this effective security? Is the amount of money and manpower that we spent, you know, putting barriers in front of this system worth the effort versus, you know, by more carefully auditing the code? I don't know. Don't have an actual conclusion on that, but I think it's worth pondering. Which brings us to more generic analysis of other parts of the security industry that isn't just web application firewalls and hardware. So Dave tweeted this at the start of the year, and this always really resonated with me because it matches most of the interactions I've had with people that are on the defense side, the malware analysis side, and also a lot of the arguments in the disclosure debate seems to revolve around a similar mindset. And Marcus sort of echoed a similar thing. Now, they're going to be fair, this is a little out of context. I was talking with Marcus about the release of proof of concept exploits in this case, rather than specifically malware or security software. But this statement is something I've heard over and over and over, so I think it's fair to include it. And that is that, you know, supposedly a large portion, or not large portion, the majority, like 90% of malware attacks are done by people that couldn't think to change a character or alter a comment in the code, or, you know, modify an exploit. They just run what somebody has given them, following a dictionary or you know, process list, a checkbox. Run this command, run that command, receive ransom. Which, yeah, I don't agree with, but you might. It's good to keep both of these views in mind as we sort of discuss the next things, I think. So we'll start straight off with detection rules, which is typically done for malware. But we're also seeing a larger demand for web-based detection. So the first one is obviously the famous Eigelbeigel Globglyph attack, which I'm sure you're all familiar with. And if you're not familiar with it, it's because it's not famous at all. But it isn't supposedly an actual attack. It's a problem where supposedly unit tests in open source software is being tagged by some enterprise security software. And I don't know which enterprise security software it is, because somebody just sort of pointed me to this. And their initial analysis is that I'm to blame for this, which may be true. Now, the reason why I have this in here is an Apache denial of service example. And the way it works is whenever Apache can't parse valid syntax in a htaccess file, it will throw a 500 error for every subsequent request. So the only thing this needs to do is not be valid Apache syntax, or be valid Apache syntax but maybe incomplete. So Apache syntax without an argument, right, like access log without anything to follow on, that will break it. I chose this because this is actually from text-based gaming. When I was younger, I used to play text-based MUDs. And you would get the string Eigelbeigel Globglyph when you entered a wrong invalid command. So it's like, well, it's a perfect string to be an invalid command. I have since changed that because I don't want to break unit tests by having them flagged as malware. So now it's just a a common keyword and. So yeah, good luck writing a detection rule for the word and. But it sort of, I feel it echoes the sentiment that you know, attackers aren't skilled enough to just go in and read the documentation for this file and change the words or remove the comments. But that's one example. Let's look at some other examples. Here's one for a Fortinet CV, so it's an actual exploit. And this is a Sigma rule, which is a common rule set used for SOCs to exchange rules to detect exploits. And we can see here in the highlighted section, it's looking for all these things have to match. There has to be a lang equals ... /... so some sort of traversal, and a dev cmbd web session database. So if it has both of these things, it's an attack. And that means if we can make one of these things not match, it's not an attack as far as the Sigma rule set goes. So if we just apply the power of slash, this is not an attack. You are now a nation state who just sailed through that SOC without getting detected. And when people say things like, oh, we have a virtual patch, or you know, we have detection, this is an internal system, we don't have to patch it. I feel like, again, it comes from this expectation that there is only one public exploit and no one will write their own and no one will modify the public exploits. And I think it's a fallacy we need to avoid. But maybe that was an exception, right? Maybe there aren't, maybe all the other rules are perfect. So let's look at another one. This is vSphere. So that's not an endpoint security software, but a lot of people use vSphere to contain legacy solutions. And again, it's looking for just one match in this case, and it's a path. And again, because it's a path, we can use the power of slash. And again, you just sail straight through that SOC. No one detected anything. So yeah, right. But what about some nation states who are skilled at like defending against other nation states? Well, they published this set of Yarrow rules, and you might see there on line 332. It matches my hand, and so I'd like to think that's because I'm an NSA-approved cyber weapon. But the truth is, NSA just grabbed this from somebody else, and the reason apparently is that my HDXS shells contains my nickname, and no one is skilled enough to modify the HDXS shells. So this is a good enough detection. And of course, if you Google HDXS-based web shell, there's a whole bunch of like Russian forums that have HDXS-based web shells without my nickname in it. So again, this is just pandering for like the bottom whatever percentage. And if you're not in that bottom whatever percentage, you get a free pass. Like they're not even going to try to run a detection. Anyway, here's some not Sigma rules. These are Yarrow rules, because if Sigma's bad, then Yarrow must be the solution, right? And again, this highlights some of the problems with text-based detection. So this is a detection for a vulnerable Tomcat configuration. You can use this to place a backdoor called GhostCat. And it looks for a couple of things. First, it looks for the file has to start with XML at byte 0, and the file size has to be less than 300 kilobytes. So being XML, you could just pad it out with spaces and you'd be fine. But let's say that you couldn't. It then looks for a service named Catalina and a connector port. And then it defines a couple of false positives that shouldn't be in there. So if one of the false positives are in there, then it's not a thing. We see that the first false positive line is the detection line, but with a comment, XML, HTML comment in front of it. And the reason why is because the text matching for V1 can't look outside the text matching to see what's around it, because it's just text matching. It's not parsing the XML to understand it. So connector inside a comment will match. And so therefore you also have to have a match for connector with a comment. But again, if we take the time to read detection rules to avoid detection, we can just define both the connector and also on the line underneath have connector with a comment, because there's nothing saying that you can't have two. The commented out, it would be ignored by the XML parsing, but it will trip up the detection. This one, unfortunately, does not use the power of slash. Here's one from the Australian Cybersecurity Centre. They gave out some guidance on F5 traffic management exploitation. The same thing, it's looking for a URL containing selection and selection 2 or selection 3. And in all cases, it's both selection and selection 3, it's paths. So again, the power of slash, and we can sail straight past the detection. And so now that we've made fun of both NSA Cyber and Australian Cybersecurity Centre, it's only fair that we make some fun of the UK version as well. They had some APT indicators of compromise. So if you want to search your logs for Dana HTML5 guacamole, which was SSL VPN, I think, Pulse VPN. I think it was Pulse VPN. But again, power of slash and your IOCs are not matching. So this is something that everyone gets wrong. Right? Now, for the actual conclusion, I'm going to defer to somebody else, but I thought I'd put the tool releases up. So you get Travesty, PHP Omelette, HDE Shell. So I have some other tools as well. They're all on my GitHub. And yeah, for the actual conclusion, let's look at what Halvar Flake said. And I think this, I mean, he said this years ago, but I still think it's true. We're talking about something that very often only works as long as no one has looked at them with the intention of breaking them or bypassing them. And then they want to be dropped in privilege points in your infrastructure. So either sitting in your DM set, maybe at the edge network in the case of like a VPN solution. They claim security, but we don't have a good way of vetting them for security, right? You don't know whether or not the F5 appliance you just installed have an executable stack, is written in C, and is actually full of memory corruption vulnerabilities. Like, you just don't know, and we can't vet it. So if you're looking to buy something, take your time, think about it. Is it better to think about it from a different perspective? So one thing I like to throw out is, if you expect this to fail, like all the security controls you put in front are going to fail and this device is going to get owned, how would you deploy it differently if that was the case? So a great example is, let's say that someone needs to open attachments that come in through the web or an email, and you're like, well, we want to use this multi-engine antivirus solution, we want to do content disarming, a lot of complexity, as opposed to, well, if it's only opened with like a remote viewer or open on a VM that is immutable, so you can't write to disk, it lives for, like the whole lifetime of the VM is a minute, right? It's just enough to boot up, display the thing, dump it as a screenshot into an S3 bucket. And it doesn't have network connectivity anywhere else, right? You can just read from one S3 bucket into another S3 bucket, and it only lives for like a minute. Chances of, even under successful exploitation of that VM that gets blown away, you're probably fine. And firing up that solution might be better than spending money on some vendor who promises you that their solution is the best and has no vulnerabilities. The truth is, hackers don't care. They will look at a solution. If your antivirus or your backup solution or your VPN provider is their way into your network, and they can hack it, they will hack it. Like, you don't get a free pass just because you're a security vendor. And that is actually the final conclusion.